Okay, so I'm not here right now, down in Georgetown, so here is the notes for today. You should be done with your skills check by now, and I will do my best to get those graded. That'll be the first grade for the six weeks, or the last 6 weeks. If you did not get my remind about the retest, you can either take this. I sent it out today, which is Tuesday, but you can take the retest on Thursday during advisory or Friday morning. By the time you hear this, the Wednesday advisory will already have been passed. So, getting in today, we're going to talk about properties of logarithms. So, exponential. Remember, we talked about exponential properties, which we'll review real quick at the top of these notes. So because those have properties, that means we can also have properties for logarithms, and they're very similar. So if you're good on the exponential properties, you should be fine on the logarithmic. So let's go ahead and get started. Remember, if you are multiplying, so looking at the top where it says recall, if you're multiplying like bases, which those have the same base of a, then you can multiply your exponents. If you are dividing like bases, you can subtract those exponents. If you are raising a power to a power, a to the power of m to the power of n, then you can multiply those, m times n up there. Okay. This is the rational to radical. Okay, this is the one where we talked about levels, where you just take them straight across. So the denominator of the exponent is what would go in front of the radical. A is what goes underneath the radical, and that is being raised to whatever the numerator of that exponent is. You've got the zero property, which that is anything to the power of 0 is equal to 1. Okay, so those are basically, those are the important exponential properties that we talked about. So now we're going to come down and we're going to talk about similar ones with logarithms. Okay, so here I've got log base b of u times v. Okay, so however many terms you have, that's how many log base b's you're going to write out. Okay, this is what I call expanding, because you got one log and you're going to expand this to numerous logs. So that is going to make this log base b of u plus log base b of v. Okay, I get the u from here, I get the v from there. So if I was multiplying, and now that means I can add those two logs on the quotient rule, I am dividing. Sorry, I forgot to go over here and do the natural log. Anything that we have on the log, it's going to be the exact same for natural log. Okay, so natural log u plus natural log v. So going back over to the quotient rule, I'm going to have log base b of u, it's going to be the numerator, minus log base b of v. And again, for natural log, it's going to be the exact same thing, just with the natural log. So natural log u minus natural log v. The next one, the power rule. This is the one it's a little weird. Some people have a hard time grasping it. Once you do, though, it's pretty easy. If you got log base b, and then this is being raised to a power, what you can do with that exponent is you just move it to the front, and it becomes a coefficient of that log. That's all. So if I've got that, then I can have n log base b of u. Over here I can have n natural log of u. I've just moved that exponent to the front. Okay, so we're going to use these properties. The first few we're going to go through and we're going to expand. That means you'll be given a single log and you're going to expand it to multiple logs. And then after that we'll do condensing. So you'll have problems that have multiple logs, such as those, and you will condense them down to a single log, such as the problems that you're given on there. So let's go down and look at those. Let me zoom in a little bit so the people in the back can see it a little bit better. Alright. So on this first one, we're expanding. So I've got log, and then I have 5 times x. There's a coefficient and a coefficient and a variable in there. There's two things essentially. There's two bases, the 5 and the x. So if I'm multiplying that, I can expand multiplication by using addition. So log 5 plus log x. Alright, going to number 2. So I've got log base 3 of x to the power of 7. So because of that, I can use that power rule, and all I need to do is just move that 7 in the front, and that is going to become a coefficient. 7 log base 3 of x. That's it. Alright. Now, whenever you have those two things combined, I've got 3 different terms here, 3 different bases. I want to expand the multiplication, so what we did on problem 1, I want to do that before I deal with the exponents. So I've got 3 different bases, 4, x, and y. So for each base, I'm going to need a natural log. And since I'm multiplying those bases, I can expand multiplication by using addition. And then now, within each log, if it has an exponent, which these two do, I can move those to the front of the log that they're on. So natural log 4 plus 2 natural log x plus 3 natural log y. And then that would be my answer. That is as expanded as that can get. Okay, so now going down to problem number 4. So I've got log base 4 of a fraction, 10 divided by 3. I can expand division by using subtraction. So log base 4 of the numerator, which is 10, minus log base 4 of the denominator, which is 3. And that's the only thing that I can or need to do on that one. So, this next one, it's got 3 different bases, 6, x, and y, and there's multiple things going on here. So the first thing I want to do is I want to split up the multiplication and division things. So first I go to the numerator. I've got natural log 6. It is being multiplied to x cubed, so I'm going to expand multiplication by addition. Natural log x cubed, and then after that it is being divided, so I expand division by subtraction. Natural log y to the 4th. Then I go to each term. If there is an exponent, then I'm going to move it to the log that it's attached to. So I've got natural log 6 plus 3 natural log x minus 4 natural log y. Okay. Going to number 6. You want to rewrite this with an exponent because there's really no property that talks about a radical. But we know that square rooting something is the same as raising it to the power of 1/2. Okay, so because I've got this parentheses right here, I need to deal with that 1/2 first. So I'm going to have 1/2 log base 3 of 9x. Now, if I expand this multiplication after I've moved an exponent, that means that you're going to have parentheses. Okay, because that 1/2 was originally attached to both the 9 and the x because both the 9 and the x were underneath the radical. And so I end up with something like that. Okay, so those are all examples of taking something and expanding it. Now we're going to take multiple logs and we're going to condense it down to 1. And you're going to do all these operations. You can do all these operations in reverse order. So previously, whenever we're expanding, we wanted to deal with the multiplication and division first. Well, now we're going to deal with it last. All right, we're gonna condense addition by multiplication or condense subtraction by division. But before we do that, we want to deal with any coefficients that are in front of the logs. Okay, so I can take those coefficients and I'm going to make them the exponents of those logs. So I've got natural log 2 to the power of 6 plus natural log y to the 4th. And now I can condense addition by using multiplication, which 2 to the 6th is 64. And then I've got y to the 4th. Okay. Now going over to 8, again, I've got coefficients. So I can move those to as the exponent. So I've got log of x to the 5th minus log y to the 4th. And now I've got subtraction in this problem. And I can condense subtraction by using division. So log of x to the 4th over, x to the 5th over y to the 4th. Okay, coming over here, I've got 1 to number 9. I've got one coefficient that I can move to the back. So I've got log base 5 of 4 plus log base 5 of x to the power of 1/3. Okay, I can condense addition by using multiplication. So log base 5 of 4x to the 1/3. You could also write this, you do not have to, but this could also be log base 5 of 4 times the cube root, because remember, raising something to the power of 1/2 is the same as square rooting. Raising something to the power of 1/3 is the same as cube rooting. You would not be counted wrong if you wrote it the first way. Okay. Let's go ahead and skip. We're not going to do 10, just for the sake of time. So go ahead and flip it over. On problems 11 and 12, don't overcomplicate these. They're telling you what these values are. Okay, so the first thing we want to do is we want to expand them so that it's log, the x, the y, and the z all have their own log base b. So I've got 3 different bases on this problem, x, y, and z. So I'm going to have log base b of x plus, because x times y x and y are being multiplied together, log base b of y minus log base b of z. And then after that, it tells you what those values are. Log base b of x is 4. Log base b of y is 3. Log base b of z is 2. So it's just 4 plus 3 minus 2. That is 7 minus 2. So your answer would be 5. Okay. Going to 12. So here you've got this. So I'm going to expand it first. I've got two bases. So I'm going to have log base b of x plus, because it's multiplication, log base b of z squared. Now I need to take that squared and I need to move it in front, make it the coefficient of that second log base b. And like these up here say, log base b of x is 4 plus, now it's going to be 2 times whatever log base b of z is, which is 2. 2 times 2 is 4. 4 plus 4 is 8. Okay. So, I want you to work together on 13 through 22. I'm going to be putting these answers on here, and if you could pause the video to give the students a little time to work on each problem, and then she can play it until an answer pops up. The sub can play it till an answer pops up, and you can check your work. Okay, so please pause the video now and give the students a little bit of time to work on these problems. Here's the answer to number 13. Log base 3 of 4 plus log base 3 of x. Here's the answer on 14. 5 times log base 5 of x. Here's the answer on 15. Log 3 plus 4 log x. Here's the answer for 16. Natural log 12 minus natural log 5. Here's the answer to 17. 1/2 times, so this is in parentheses, log base 3 of 9 plus log base 3 of x. Here's the answer to 18. Natural log 4 plus 2 times natural log x, because it was x squared, plus natural log y. So there are the answers to all of the expanded problems, and then the next one will be the condensed. Here is the answer to 19. Log base 4 of 7 over 10. If you put log base 4 of 0.7, that's the same thing. Here's the answer to 20. log x squared over 11. Here's the answer to 21. Natural log of 8x to the 7th over y cubed. And here is number 20, which I'm going to walk through up here. We'll explain this. Let's see if you can get what this is. So this is the answer to this is log 50. Okay. So there are the notes for today. Now you'll be getting your homework. I will check both 12.1 and 12.2 homework next Tuesday and Wednesday, whichever day I have you. Those will be the first homeworks of the 6 weeks. The first daily grade will be the skills check that you took today. And if you have not retested and you need to retest at this point, the only time you can retest will be Thursday during advisory, or with Miss Green in D217, or Friday with Miss Blanton, Friday morning at 8 a.m. with Miss Blanton in D202. So if you need to retest, you need to find those 2 rooms at those 2 times so that you can take it. So have a good weekend. If you are traveling down to the soccer game, then please drive safe.